Hello everyone, how are you? So today we will continue with function and we will see some other properties of this type of objects in Python. So we will see how to pass keywords to a function and the notion of recursion in functions. So to begin with, we will see how to pass some keywords to a function. So in principle, any function in Python accepts keywords. For example, if we write some keywords like those here, B and C, and we'll close the parentheses. Now the colon will return to the line, and we just ask the function to print for us the sum of those numbers if there were numbers. They can also be strings, no problem. So just like this. Now what if the arguments are keywords? What that means, for example, here we forgot to define this function. We will name it, for example, combination, so comp. So this, if we call this comp function with keywords, for example, e will be equal to, for example, 12, b will be equal to for example 23, and c will be equal to 34. So what we will find, of course, the sum of those numbers. Good. They can also be strings, for example, names, Bob, here, for example, Alice, and here, for example, Jane, for example. So if we want to make a combination with them, we have to let here some space in order to not glue them one to each other, but we'll make them just 3 words like this. So this function, and each and every function in Python accepts keywords as arguments. Good. Now what if we don't know how much arguments will be passed to this function? We have seen yesterday that for direct argument we use this notation with asterisks and the arguments. Now we see that we can use for keywords another notation, which is the double asterisks. So for example, arguments, arg. So what can we do, for example, with those keywords? For example, we'll first define or assign a value to s, for example 0, or this empty string, and we will use a for loop in order to scan these keywords one after another. So for example, name, in what? In those keywords. But we see that, for example, here we have the name or the keyword and its value. For example, we don't want the keyword, but only the name. So we will specify that we want this arg, but only its values. So values is a method in Python that specify that we want the values of a keyword. Good. So what we will do with this name? Only or simply we will add it each time to s. So add this name. So this is what we have to do. Here we have mistake the name, so arg. Good. So and finally we will just print that, so we have nothing to return, we just print this s. So now we can see our results. If we add another value or another keywords here, for example d equal, for example John, so we will have, but we have to let here some space in the name of Jane, so we'll have our 4 names. Good. So this is what we do with this double asterisks in keywords in function that we use a variable number of keywords. Good. So this is how it's function. Now we see the notion of recursion. So what is recursion? Simply that means that a function f when or so the definition with the definition. So if we define a function, so func or fun with some arguments, inside this function will call itself. So in its definition will call itself. So with some instruction we will find it calling her or itself with these arguments or same false. So this argument and for example another instruction. So this is what we call with recursion. So this type of function recur or call itself inside the function. So before even finishing to define this function, it can call itself and use itself inside her or its definition. So we'll see a simple example. For example, so we'll see what we call in math the factorial. So what is a factorial? Factorial is simply a number, for example 5 with this mark of exclamation, which simply equal 5 multiplied by 4 multiplied by 3 multiplied by 2 multiplied by 1. This is what it means. So this recursion to multiplication by minus 1 is an example that we will use this recursion of functions. So we'll define a function that we will call facts. For example, so an argument will be n, which will be the number. For example, here in the example is 5. So what we will do is, but before this we have to define a product here that will each time multiplied by a new number, which will be equal to 1, because if it will equal to 0, all the results will be equal also to 0, because this is multiplication, not addition. So what we can do, so we'll ask it if n is bigger than, greater than 0, what it will do? Simply it will multiply this pi each time by what? By n. So n each time it will be equal to 5, to 4, to 3, and it's so on forth. So, and each time, or in each turn of this recursion function, here we have no loop, but recursion function are a type of loops. So in each call of this function, n also will be diminished by 1. So 4, 3, 2, and so on and so forth. And when we finished of multiplication and subtraction, we will call this function, which is fact. This is the notion of recursion. With what argument? With n, but remember that n now it is not the first n, but the new n, which is diminished by 1. And this is what we will have each time until this condition is not satisfied. So here we will no more calling this function, and we will simply return the value of this p. So this is what we will do. So to revise, here we have defined the fact function, and here we have given to it a condition. So the condition is that n must be greater than 0, and each time in each call of this function we will multiply p by n and diminished n by 1 and call this function. Of course we will call it, but it will not be executed until this condition is satisfied. And finally, when n is equal to 0, the function will return us this value of p. Of course it will be each time returning p, because each time this function will have this return inside this, but the last return is that with what the global function will give us. Of course, so if we print this function with some value, for example 5, like here, we'll have nothing, because here is an error. What is this error? Local variable p referenced before assignments. So this notion of local and global, we'll discuss it in the future sessions, but here we will just fix the problem. So of course, why there is a problem? Because p here is not defined. It is defined outside of the function, but inside the function it is not defined. So we have to tell to this function that that p is global. So we use this keyword which is global, and we add the variable. So global p, now it will function, and as you see it is equal to 120. So here we can give the results. It is equal to this. Good. So this is how recursion function in Python. So first of all we define a function, and inside the function we call this function. So the sum function fact, and this call will be repeated until the condition is no more satisfied. So be careful. This notion of recursion is a little tricky, because if you didn't define the condition correctly, it might be work indefinitely, it will work infinitely, and the program will not return anything, because it will works without stopping, or it will consume a lot of memory. So be careful in indicating the condition. If not, this function will not give you anything, because it will not be able to stop itself. But if you define the condition correctly, you will have a beautiful and mathematical writing of your function. So when we use it like this, it is more beautiful and more efficient in working. So this is what we have today. So we have seen the using of keywords in a function, and the using of double asterisks in functions, and how to use and to define recursion in a function. So thank you for watching, and see you in the next session.